File systems are built on top of a selection of LUNs. LUN, which stands for logical unit number, is a logical storage device. In the simplest case, a LUN corresponds to the entirety of a single physical storage device, such as a hard disk drive. But commonly LUNs are created out of a larger pool of storage, either by dividing large physical devices into smaller logical pieces, or by combining individual storage devices, as in a RAID set, and then slicing across them. StorNext file systems are no different in this regard. However, StorNext introduces two layers of abstraction between the LUNs and the file system that provide important expanded capabilities. These layers are stripe groups and pools. Stripe groups are mandatory and detailed in a separate video. This video is the first in a short series about pools. Pools are optional, but very useful, as you will see. A StorNext file system pool is simply defined as a collection of one or more stripe groups. A stripe group, in turn, is a collection of one or more identical LUNs. Where multiple stripe groups comprise a pool, they will typically be the same class of storage, such as NVMe flash or SATA hard drives. Each pool has a name defined by the administrator, such as slow or fast. As with stripe groups, pools are transparent to end users and applications. Pools are all part of the StorNext file system namespace. Files in all pools appear in the file system together. You may be wondering, what are pools good for? Pools enable a very useful function, primary storage tiering. Primary storage tiering allows administrators to manually or automatically move files between pools. This is valuable when files have different performance needs at different points in their life cycle. For example, nonlinear video editing, especially at higher resolutions and frame rates, requires very high bandwidth and low latency storage. This is a perfect application for NVMe flash. Once the editing is complete, the content can live on lower performance, less expensive hard drive-based storage, where it is still accessible for other uses. Movement of files between pools is accomplished using jobs and policies, which are the subject of Part 2 of this series. Another use for pools is to isolate project content, so that activity on the files for one project does not impact performance on other projects. For example, with two projects named Red and Blue, if each has its own pool, high-performance access to their own files may be guaranteed to both teams, with no contention for storage bandwidth. Hard disk storage provides inexpensive capacity, for primary storage anyway, but it takes a lot of hard disk drives to obtain high performance, making them expensive in terms of price performance. NVMe flash is almost the opposite. On a capacity basis, dollars per terabyte, it's quite expensive. But because each individual NVMe storage device is so fast, it has great price performance. Traditional SSDs land somewhere in the middle. Using StorNext file system pools, you can take advantage of the best attributes of each type of storage as your work demands it, without the need to manually copy files between file systems or storage arrays. In the first video, I explained what pools are and where they fit into the StorNext file system architecture. Pools facilitate the movement of files between different classes of primary storage within a single file system. This enables the most efficient use of high-performance storage assets. Moving files between pools is accomplished using jobs and policies. Jobs are data movement tasks that are run once, either immediately or at a defined point in the future. Jobs are good for ad hoc data movement where the timing or files needed may not be predictable. Policies, on the other hand, are data movement tasks that run on a schedule. At the appointed time, a policy will wake up and look for work to do based on criteria set in advance. It will complete any work found and then sleep until it's scheduled to reawaken. Configuring a job is simple. From the Jobs screen, click New Job. Select the file system the job will apply to, and then choose the action to take. The basic job type is Move, A move job will migrate selected content from its current location to the target pool, assuming it is not already there. If directories are moved, new files created in those directories will reside in the target pool. Promote and demote jobs work in concert. A promote job makes a copy of the selected content in the target pool, leaving the original content intact. When a demote job is run later, files that have not been changed are simply reverted to the original, and the promoted copy is removed. No data is moved for files that haven't changed. A move is executed for files that have changed, capturing the updates. Using promote and demote consumes more storage than two move actions, but for read-only use cases where files won't be changed, it offers much faster reclamation of space in a pool. Remove jobs are used to remove files and directories from pools, and may also be used to clean up old copies created by promote jobs. Inventory jobs scan the contents of the specified location and build a report showing the space being used in different pools. During move, promote, and demote jobs, there is a checksum option. If this checkbox is selected, the checksum is generated for each file, both before and after the move or copy. The checksums are compared to ensure the data is intact before the action is committed. In advanced mode, there are also checksum and validate actions available. These operate a little differently than checksums run during a move, promote, or demote. The checksum action computes a checksum on each specified file and stores it in an extended attribute. This enables the validate task to be run at any time, even months or years later. Validate computes the checksum for each file and compares it against the stored value to ensure the file has not been changed. Once you select an action, you specify the target pool, the root path for the job, whether it acts recursively or only in the root directory, and optionally, an email address for notifications. In step 2, you specify any filters needed to winnow down the selection of files to be acted upon. Multiple criteria may be stacked. Filters include file size, last access time, files matching a specified regular expression, and more. In this example, the move job will only act on files 40 megabytes in size or larger that haven't been changed or accessed within the past day. This requires stacking two simple criteria. Finally, in step 3, you select whether to run the job now or at a specified time in the future. Policies are configured in a very similar way. After giving the new policy a name, the task screen is the same as for jobs. The filters screen and options are also identical. The Scheduling tab lets you specify when the policy runs, daily, weekly, or every n minutes or hours. At the specified times, the policy will query the metadata database to find work to do and complete the specified actions. Using the metadata database avoids the need to scan the file system.